Welcome to the final part of our 4-part series where we've been building an app to store and share important family stories with FlutterFlow. We've come a long way from the essential setup in part 1 to incorporating audio recording and transcription in part 2, and then engaging animations and dynamic components in part 3. In today's video, we're focusing on integrating search functionality and AI actions into our FlutterFlow project. We'll enable users to easily find specific recordings within their collection and explore how to analyze the content of those recordings. This video will demonstrate the power of FlutterFlow's integrations and how you can use them to truly build intelligent and feature-rich applications. So let's finish strong and make our legacy app not just a memory, but an essential part of family history. Now, before we dive in, a heads up that everything we build today is already live in Knack, FlutterFlow's microlearning app built entirely in FlutterFlow. You can explore it, learn with it, and even vote on what we build next in this series. Check it out on the App Store or Play Store. Links in the description, or just scan the QR code on screen now. FlutterFlow has an amazing new tool called AI Agent Builder. It allows you to integrate AI capabilities securely without ever having to construct your own API call or use custom code. AI Agent Access is tailored to your FlutterFlow plan, and it's available on standard plans and above. As you'd expect, these agents can be customized with specific instructions, but are far more integrated into FlutterFlow as you're able to dictate the inputs and outputs an AI agent is going to produce in the familiar FlutterFlow environment. Let me show you how easy it is to use agents to get a summary of every user's entry once they've recorded it. You'll find AI agents in the side panel. Click on the AI Agents button and create a new agent. AI agents tend to be centered around a model and a task. So when you're giving it a name, to aid in its recognizability later on, you might want to consider including its model and task in the title. Next, I find it's easiest to head straight across to the model settings, so you can set the AI provider you're looking for and the model that best suits your needs. If you're using the OpenAI or Anthropic AI models, you'll need an API key. You'll find this at playground.openai.com or at console.anthropic.com. You can send your request either as plain text or as an image, and you can receive your response back in a number of different formats. For example, you can just receive plain text. You could receive the response in Markdown, which you could then use FlutterFlow's Markdown widget to display nicely in your app, or you can choose to receive a structured JSON response. For our AI summary in Legacy, we're going to want our AI agent to always return a structured response. So we can pass that and place it in our UI in the sections that we need it. It'll also make it easy for storing in our database. Below that are some model parameters which will be familiar to you if you've ever used any of these models outside of the API call method. The most important one is probably temperature, which will define how creative your model's response is. A 0 is very prescriptive and a 1 is extremely creative. For the most part, these are fine left as defaults. Next, you'll want to give your AI agent a description. Now, this is just an internal description. It's actually just for you and your development team, and it won't be sent to any AI model. Instead, you'll want to include all of that important information you want your AI model to know inside your system message. The system message defines the overarching task the AI model is required to perform. And if you've asked for a JSON response, you'll need to make sure that you specify the JSON schema that you want received back in this section here. Here we're defining a simple JSON response that just has one key, summary, which, as the name suggests, will be a detailed summary of the entry our user has just provided. You can optionally provide a number of pre-recorded messages here to give your agent context around what's already been discussed between the user and the agent. Then all that's left to do is hit deploy. What FlutterFlow is doing here is creating your very own custom function within your Firebase custom functions section. That does, however, mean that you need to be using Firebase for your project to deploy either an OpenAI or Anthropic agent. But we do plan on implementing deployment without Firebase in the future. The great thing about this is that your API key will always be secured in the custom function, as will your business logic and your system instructions. The Gemini agent has a slightly different set of requirements, as it uses the Firebase Vertex AI integration. So you'll need to check that you have the Gemini API turned on in your Firebase console. The step-by-step instructions are here, and they're quite easy. One big advantage of the Gemini agent, and it's an especially big one for our project, is the larger range of multimodal input options. Using any of the 2.0 models or above, we can provide Gemini audio as the agent's input. This means we can send Gemini our user's story and have it provide back a JSON object containing both the transcription and the summary, not to mention anything else you'd like Gemini to return. Think about things like some sentiment analysis, a list of topics covered, places mentioned, and much, much more. This removes the previous individual transcription step entirely and saves our users a bit of waiting time. It does mean, however, that our action flow editor needs a bit of work. As you know, we've got a button here which initiates the recording of our user's story. I've removed the previous transcription step, and we're now going to use our Gemini agent to do the transcription and summary at the one time. In order to give our agent the audio of our user's story in a file type it can process, we need to include this small piece of custom code, which I'll include in the description below. This code takes the file path of the audio file which our stop audio recording node has saved locally on the device. It reads the audio data and wraps it in a special package called an FF uploaded file. FlutterFlow knows how to handle this, as does the new Gemini agent node that you'll find here in the right-hand menu. And there are two options we can choose from. The first one is send message, and the other is clear message. They do exactly what they say on the tin. For our summaries, let's select send message, and we'll select our Gemini agent. The first thing you'll do is give your agent a conversation ID. The conversation ID is what each agent will use to track the individual conversations it's having with all of your users. So it's incredibly powerful. Because we've structured our data model across 3 levels, we effectively have 3 different options for the way that we can provide our conversation ID. By being smart about the way we set the conversation ID, we can dramatically change the output that we get from our agent. For example, we could provide every single entry the user has made, regardless of era, by having the same conversational ID every single time. For example, we could set the conversational ID to be the user's user ID. Similarly, we could provide all answers within a specific era by providing the conversational ID as the era ID. That would mean every response that came back from our agent may or may not reference other entries contained within the same era. Finally, we could provide just the answers recorded under the specific entry ID, meaning that the agent will only ever have knowledge of the question that's been asked. And this is what we'll use for legacy. There is, of course, a fourth option, which is to give no conversation ID to your agent at all. Let's call this goldfish mode because effectively it means that each new call to our agent will be fresh and new for the agent, without any context other than the pre-filled messages you may have given it in the Agent Builder setup screen. The difference between option 3 and option 4 is that should a user go back and add something to their entry, not that we have that facility built in at the moment, but we could, the agent would have knowledge of both entries under that one entry ID. In short, one of the greatest things about FlutterFlow's Agent Builder is that it makes it really easy to give your agent the history and context you already have stored as part of your FlutterFlow project without the added complexity of an API call. Let's finish off the rest of our Action Flow Editor nodes. Below our AI agent node, we're updating the page state. This will show our user where we're at in the transcription and summarization process. Once that's out of the way, we can update our database. Here we're creating our entry for the user. We're providing the question ID from the parameter. We're entering a created by user ID, which is the authenticated user's user ID, a start time from our page state variable, and end time, which is the current time, our audio from our upload media to Firestore node, the question text for reference, and this comes from the question document that we've queried, the question index, which is equal to the page view that we're currently on, the name of the user providing the entry, which is the display name, and last but not least, our transcription, which comes from our agent. And because our agent is providing a structured JSON response, we know that it will always be at the JSON path, which is $.transcription. Similarly, with the summary, we know that it will always be at the $.summary JSON path. And once that's all complete, we'll reset the record date time as well as the state. And we can do that in the one node. So I'm combining them here. Now let's prepare our UI to display our summary and transcription together. At the moment, our component is just displaying the description as a text widget, but we can probably make it look nicer than this. The expandable widget has a collapsed view and an expanded view, and it will allow us to show the first line of our summary and the first line of our transcription and allow the user to click on it to expand to see the full text transcript or the full text summary. So here we've added an expandable widget and we're going to provide it with the summary field from our entries collection and also give it a default value. As you see here, we have to set up both the collapsed and the expanded views. And we'll do the same thing with the transcription field. We'll duplicate our expandable widget and provide it with the transcription field from our Firebase document. By default, the expandable widget has a height of 200 pixels. We can remove that because we have access to the implicit animation field, which will expand our container to the full width that's required over the time period that we define. Here we're defining a time period of 1200 milliseconds or 1.2 seconds. This will provide a nice, clean expansion of the widget. Let's test it out. A comprehensive, fast, and accurate search function within an app can be that piece that sets your app apart from the pack. The all-important final 20% that really makes all the difference. Algolia has been integrated into FlutterFlow from the very beginning. And while newer players like Melee Search have entered the field with their own take on in-app and AI-assisted search, you'll be hard-pressed to find a more versatile and genuinely powerful search-as-a-service platform. It just works, and it works fast. Now, before we jump in, a couple of prerequisites. Firstly, Algolia integration in FlutterFlow works hand-in-hand with Firestore. So you'll need Firebase set up, specifically using Firestore collections for the data you want to search. Secondly, to make the magic happen with syncing of data, your Firebase project needs to be on the Blaze plan, and this is because we'll be using Firebase extensions. We've already set these up for our legacy project, but if you're just jumping in here for Algolia, just know that those couple of things are a must. All right, let's get setting up. First stop, the Algolia dashboard. If you don't have an account, you'll need to sign up, and they have a free plan to get you started. Once you're in, the first step is creating an application. Think of this as your main container for your entire search project. It makes sense to name it the same name as your app, so we'll call it Legacy. Next up, we need an index. An index is where your searchable data actually lives within Algolia. The crucial part here is to name your index exactly the same as the Firestore collection you want to search. So for Legacy, we'll want to be searching the entries collection, so our Algolia index must also be named entries. Now we need a way for Firebase and FlutterFlow to talk securely to Algolia. For that, we generate an API key. Head over to the API key section in Algolia settings. Make sure you grant the necessary permissions. The documentation lists them out, but they're add object, browse, delete index, delete object, settings, edit settings, list indices, and usage. Give it a description, and match up the indices. Add in the validity, and create. Copy this key somewhere safe, because we'll need it in the next section. Now, how do we get our Firestore data into that Algolia index automatically? Well, we'll use the official Algolia Firebase extension. Head over to your Firebase console, find the Extensions Marketplace, and search for the Search Firestore with Algolia extension. Click Install and follow the prompts. It'll ask you to review billing, the resources it will create, like cloud functions, and the access it needs. The key part is the configuration. You'll need to provide the collection path, which is the name of your Firestore collection. So for us, this is entries. Which fields within your collection you want to index if you don't want to index everything. The Algolia index name, which is the index we just created in Algolia, again called entries. The Algolia application ID, which you can find in the Algolia dashboard, in the URL, or in settings. The Algolia API key is the key that we generated earlier. Firebase will help you store this securely as a secret by clicking this button. And importantly, set full index existing documents to yes if you want to sync all of the data you've already got in your Firestore collection immediately. Choose the Cloud Functions location closest to where your data is being stored in Firebase and give it a few moments. Brilliant! Firebase and Algolia are now linked and syncing. The final step is telling FlutterFlow about our Algolia setup. We'll go into Settings, and under Integrations, we'll find Algolia. Enable the integration. You'll need to paste in your Algolia application ID again, and this time you need the Search API key from Algolia. You can find this separate key in your Algolia API Keys section. It has read-only search permissions, perfect for the client side. Finally, under Indexed Collections, select the Firestore collection or collections you've configured, and that's setup complete. FlutterFlow gives you two main ways to access search with Algolia. There's the Algolia search query. It's perfect for when you have a dedicated search button next to a text field that the user types in and hits search. You pass the search term to a dedicated page or component which runs the search query on the specified index. Alternatively, you can have a search update in real time by using a text field that on text change runs the Algolia action in the action flow editor. You run this on the text field that's being updated. Which then updates a multi-child widget, such as a list view, giving you that super slick Google-like search experience. Using a combination of FlutterFlow's powerful features is where the magic really happens. For example, you can use a combination of the Algolia search action with the autocomplete feature of a text field. So when the user updates the text in the text field, this triggers an Algolia search and updates a list of search results that magically appear auto-completed below the text field. This works best when you have a list of titles or names that people are searching for. As you can see with Legacy, we don't really have the same thing, and returning a summary as I'm doing here isn't quite right. For Legacy, I've created what looks like a search field on our app's homepage, but when clicked, we'll actually navigate to a dedicated search page. And this search page has the real search field with an autofocus applied. The autofocus will automatically put the text field in focus when the page loads. This means that the user will be shown their keyboard. The user, being prompted with a keyboard, will enter a search term. And because the text field is set to run an action on text change, it will use the Algolia search action to run a search, updating a list view on the page. In the list view, I'm reusing our entries component to show each search result. And because it wasn't really built for this, I've gone in and added an additional component parameter, which is a Boolean that we can give the component if it is used in a search list view. This will show the summary in the search results. So here you can see the results of that. If a user searches for something like home, it will show every entry with home in it. But if the user enters something like dad, which our users have only entered once in one of our entries, it will show up the entry that's about dad. That's just a quick run through of integrating Algolia search. Let us know in the comments section if you'd like us to dig deeper into the different ways you can cut and slice your data in Algolia to deliver some really creative search results back to your users. It's a small setup cost for a big payoff in user experience in your apps. check out the official FlutterFlow and Algolia documentation for more advanced configurations. You can access everything we built today inside Knack. It's available right now on the App Store and Play Store. Hit the link in the description below or scan the QR code and you get to vote on what we build next. If you've liked this video series, please like, comment, and subscribe. Next up, we're building the great big quiz of everything. It's going to be an adventure. I hope you'll join me.